Welcome back, and welcome to 7B, Understanding U.S. Budget Priorities. This will be for the interactive tutorial, so let's not delay. Okay, so in this one, look at the budget, looking at budgets, and we'll be using percentages from ratios, pie graphs, and calculate part-to-part and part-to-whole ratios. We should have working knowledge by the end of this tutorial. Next class, you will need to be able to calculate percentages from ratios and create pie graphs using percentages. In addition, you will need to understand certain basic components of the U.S. federal budget. Tutorial begins here. Ooh, nice pie graph. Okay, so basically a ratio or a percentage is going to be looking at the whole, which is part 1 plus part 2 plus part 3 equals the whole. So anytime we do a comparison of part to whole, it'd be like, okay, part 2, part to whole. Okay, let's go with part 2 over the whole. But recall what the whole is. The whole is part 1, part 2, part 3. That's for a part to whole ratio. Part to part, you know, how does one part compare to another part? So how does part 1 compare to part 2? Or how does part 3 compare to part 1? And in this case, we'll find out whether which one's bigger. Is part 1 bigger than part 2? If part 1 is bigger, then we should get a ratio that's greater than 1. If part 2 is bigger, we should get a ratio, that's less than 1, and so forth. Now, whenever we do a part to whole ratio, though, this is important. Whenever doing a part to the whole, the best you can get is 1. Be 1%. Typically, it's going to be less than 1. 10%, 20%, 30%, 40%, etc. So let's see. A ratio that compares the size of part 1 to the size of all parts put together is a part to whole. Part 1 compared to the whole. Part 1 over part 1, part 2, part 3, because this is the whole. Now we're doing in fact, here it is. Part 1 divided by the whole. Now a ratio that compares size of parts to size of a part is a part to part ratio. So how is part 1 compared to part 2? Visually, we see part 1 is smaller, so whatever this ratio is, it's going to be less than 1. Because part 2 is bigger, and the denominator is bigger than the numerator, it's only less than 1. Okay, here we go. Table shows, here's a table of all the activities that Megan did in a typical workday over 24 hours. Looks like she was in class for 3 hours on a day. She spends 5 hours of her day doing homework, which is actually kind of low because typically for every hour in class, it should be 2 to 3 hours of homework. Works at her job, does some exercising, does some recreation, sleeps, and miscellaneous, and they should all add up to 1 day. Okay. So, percent of total time spent on activities. So for this guy, well, the part of 3 hours in class compared to the whole, do it again, compared to the whole, which is 1/8, which is 12.5%. Remember, 1/8 is 0.125. To make it into percent, we just take the decimal point and move it 2 locations. All right, so I'm going to pause, and why don't you finish completing out the next work on your own. What percentage would be homework, working on a job, etc. Hopefully you would have done something like this. The part 5 over the whole 24, the part 4 over 24, the part of 1 over 24, and so forth. And should have gotten 20.8 for homework, 16.7 for working at a job, 4.2 for exercising, 8.3 watching video, recreation, 33 and a third sleeping, and 4.2 miscellaneous. Of course, it all adds up to 100%. So we get 25, 20.8, 16.7, 4.2, 8.3, 33.3, 4.2. Okay. So again, this was an example of a part 2 whole. And of course, the whole was in class, plus homework, plus work, plus exercises, plus recreation, plus sleeping, plus miscellaneous. And that's compared to each of the individual parts by themselves. Again, as we said earlier, these were examples of part to the whole, because we were always dividing by 24 hours, the totality of the hours of the day. Okay, now sketch a pie graph by hand of Meg's activities in a typical day, illustrating percentages. Estimate the size of each section of the pie. Be sure to label each section with percentage and word label. Now, these are some oddball numbers. First about 24ths. And of course, talk about 3s, 5s, 4s of them. So I'm going to use Excel. But I kind of preload a little bit. So here we have school, homework, work, exercise, recreation, sleeping, and miscellaneous. And basically we got the 12.5, 20.8, 16, these are percentages. And the hours were 3, 5, 4, 1, 2, 8, and 1 again. Do a couple things here. Okay, so let's do a quick pie chart. Well, we do it in Excel quickly by highlighting what we want, the items and the respective percentages. Go to Insert, insert what? I want a pie chart. Do a simple 2D one. So here's a pie chart. And we have a couple of options. Let's do data labels. You don't quite like that. Arrow was have us do location center, inside. Okay, that's better. Best fit. Data call out. Ooh, I like that one. good as it is. So I'm going to go with this guy, data call out. Let me do this. I'm going to do highlight and drag, do control. Let's do it with hours instead of percentages, see what we get. Wow. Looks the same. Style. Yeah, you got the same chart. So we could have done with answers with hours also. Note it also kind of rounded the percentages to the nearest whole. So here's our pie chart. Now let's see how that compares to the what they want. Okay, homework 21, school 13. In class 13, homework 21. I think we nailed it. We did a good job there. Like I said, sometime when the oddball shapes Excel. If I mentioned that NMTC offers a great Excel 1, Excel 2 class, if you haven't done that and you're not real strong or confident in Excel, do yourself a favor. Do Excel. Take the Excel class. Okay, part D. On what three activities does Megan spend most of her time? Well, let's go back. It would appear we have sleeping, work, homework, and job. Sleeping, homework, and job. Sleeping, homework, and work. We have to quickly get that off the graph, even the ones we made. Quickly go and look at the graph and say, hey, look at the numbers, sleeping, followed by homework, followed by work. So that's something that a pie graph quickly allows you to differentiate or identify. And E, what do the percentages show about Megan's priorities? Well, the thing she has most priorities is what she puts most of her time into, I would suspect. Which are the top three hitters: sleep, work, and homework. Let's see, consider the percentage you calculate in question 1. Comparing one of Megan's category amounts to another category amount would be a part-to-part. For each following task, write the part-to-part. Express a part-to-part ratio of the hours in class compared with the hours doing homework. Okay. Now recall, we spent 3 hours in class and 5 hours doing homework. So it's part-to-part of class hours in class compared to homework. So that would be 3/5. Okay, which then becomes a decimal, which becomes 6%. So she spends only 60% as much time doing in class as she does in homework. Part-to-part of the hours doing homework compares to the hours watching TV or playing video game. Doing TV and video games were, that's recreation, that was 2 hours. Of recreation. So part-to-part ratio of homework to TV. That's 3/2 or 1.5 or 150%. Boom, boom. Oh, yes. That was maybe the question wrong. Homework. Not in class. Homework. Which is 2.5 or 250%. And get your question more carefully. Let's see, some more. Okay, so this I'm going to have to just let you all do on your own. There's really no canned answer. So like part A, what do you think national defense means, and what are 2 examples of a national defense expense? So except for the next part, A through D, look at it, go on the internet, check your answers. But for example, for national defense, 2 examples. What is national defense? Well, basically it tells me military, cost of defending USA. What 2 examples of expenses? One be military payroll. In other words, the cost of paying the people. And from my Navy days, OM&M, operation maintenance Navy. There's also operation maintenance, Air Force operation maintenance, Army, and so forth. And just so things something similar for human resources within the federal budget, fiscal resources, federal budget, and what is net interest. And that is getting more and more of a political hot potato after every year of recurring budgets of the United States of America. So again, do some internet searching to get a definition for national defense. Definition of what you think human resources means, and 2 examples in budget, physical resources, and national debt, national interest. Okay, so let's see. We should now have some confidence of calculating percentages from ratios, some confidence of sketching a pie graph, and some confidence doing a part-to-part and part-to-whole ratio. And so at completion, we have completed this tutorial, and this is what we covered. And I should see you spend some time, look up those last couple questions on those definitions of the budget, and I'll see you shortly, and I'll see you soon in doing the questions.